told you that the tendency of a body to remain at rest or as it moving in a straight line, right? We have discussed in the
Yes.
last class, right?
Yes,
And
sir.
the ability to resist the change of state is called inertia, right? And we have also discussed that inertia depends on the mass of a body. Heavier object have more inertia than lighter objects, right?
Yes.
Okay. So now let me write down the first law of motion here. So, I think so already written. I have already written it. Yes, it's already written. Yeah, here it is. So as you can see this thing, Safia, this is the first law of motion. Okay. So a body at rest will remain at rest and a body in motion will continues in motion in a straight line with a uniform speed unless it is compelled by an external force. It means that unless an external force is applied to the body, it will not change the state of rest or of uniform motion. This is the first law of Newton, right? This law is also called law of inertia. Clear, Safia? Please write this
Yes.
law as law of inertia. Please write this in your copy because that will save your time and you will do more
We have
topics.
wrote 3 points, three
Yes,
to
we have.
4 points.
Yes, after this you have to write this thing, the inertia, the law of inertia. Let me share my screen again. Actually, it's a little bit. Let me share my screen. Basically, I'm doing this thing so that we can save the time because one more topic is left, that is momentum, so that we can complete the momentum topic in this class itself with the numericals. So that in the next, in the tomorrow's class, you will be merged with the batch. Okay. This a body at rest will remain at rest. A body in motion will continue in motion in a straight line with a uniform speed unless it is compelled by an external force. Compelled means influenced or applied, you can say this thing, or introduced, like these words, right? Or making contact. Clear, Sophia?
Yes.
So that's good. Done?
Yes, finished.
Okay, that's great. So next thing is that inertia is the property of a body due to which it resists the change in the state of rest and of motion. This is already, we have already written it, right? This statement we have
Yes.
already written because this is this definition of inertia. It is the property of a body due to which it resists the change in the state of motion or rest. Clear? Now
Yes,
let's,
clear.
yeah. And we have also discussed that inertia depends on the mass of a body. Heavier objects have more inertia than the lighter objects. Clear? A bus has a greater inertia than the car. Now, okay, Safia, what we will do is that you do like right now, you just have to understand it. No need to write. I will share this PDF with you. And after that, you can write it in your own notebook or you can take the reference from it. It's up to you. Okay? Because if you write it, so that will take a little bit more time at your end as well. So I will explain it. I will share this PDF as well so that you can take the reference from it whenever it is required. Or you can also write it in your copy as well after the class. Okay. Now let's understand this thing, Safia. So these are the four things that is the real world applications of the law of inertia. Okay, and these 4 questions are very common in the exams. These are the conceptual questions. You must have heard about the conceptual questions. So these are the conceptual or explanatory questions that can be asked in the school exams, right? So the first thing that we'll discuss is you must have seen that whenever there is a carpet is hanging, if you beat it with a stick, the dust particle will come out from it. Have you seen this thing?
Yes.
Yeah. So that is the that is the effect of the law of inertia. When the carpet when the hanging carpet is beaten with a stick, the dust particle comes out of it due to the rest basically rest state. The particles are in rest state when the carpet was hanging, but suddenly when you beat it with the stick, the particle wants to basically there is a slight to and fro motion like this. There go. And the carpet is like this. When you beat it with a stick, the particle will go like this, will go like this. It will go like this. It will slightly move. Yes or no, Sophia?
Yes.
Due to that, it is a change in state. When the particle was in rest, now they are in little bit motion. So there is a change in state. So that's why the particle will tend to remain at rest due to their inertia and hence separate from the carpet. That's why they get separate from the carpet due to the rest energy, rest state. Clear, Sophia?
Yes.
When a bound hanging carpet is beaten with a stick, the dust particle coming out of it. This is because the force of stick makes the carpet move to and fro like this, a pendulum like this. When you beat it, something high hanging thing, it will to and make the to and fro motion. Yeah, slightly. But dust particles tend to remain at rest due to their inertia and hence separate from the carpet. So this is the reason the dust particle will come out of the carpet if you beat it with a stick. Clear?
Yeah.
Any doubts, Safia, so far?
No.
Chalo, theek hai. Next thing. When a running car or a bus suddenly stops, the passenger just a second, the passenger are jerked forward when the car is moving and there's a sudden apply in the brake, there's a forward jerk. You will go like this because your body was in motion and there's a sudden change in the state of your body, that is this rest motion. But your body wants to be in the forward motion, yes or no, Sophia? So that's why there is
Yes.
a forward jerk in the stopping of a bus suddenly by applying brakes. Because due to the inertia, the passengers tend to remain in their state of motion, even though the car or bus has come to rest. Even though the car and bus has come to rest, so that's why there is a forward jerk like this, suddenly like this, right? So that's why seat belt are very important in the vehicles. Because when the car suddenly stops, your body will go in the forward direction. There is a very high chance that your head or something, any part of the body will collide to the car, right? So that's
Yes.
why seat belt is preferred. When a car or bus starts suddenly, the passenger falls backward because our body was in rest. There's a sudden change in the state, so that's why we will feel a backward push, right? Like this. Have you observed these things, Sophia?
Yeah.
Yeah. So this is
Yes.
due to the fact that the inertia passengers had tend to remain at rest even when the car or bus has started moving. Clear?
Yes.
Any doubts of you till now?
No.
Right? Now it's looking a little bit efficient and then writing it on the it's is it better or the
No.
previous one was better?
This
Yes, Sophia.
one's better.
This one is better. Yeah, that's why I thought that because this is a very theoretical question. If I write it again and again, so that will take a lot of time and we won't be able to complete the syllabus on time. So that's why I thought that this should be better and I will share this PDF with you because explanation is important. Written is book. Okay, so concept is important and we have the reference as well. Next thing. So Safia, there is one more condition. Suppose that a person wants to jump out from a running bus or a moving bus. What will happen? Do you have any idea?
Can you
Yes, Safia.
repeat the question?
I'm saying if a person wants to jump out from a moving bus, what will happen to that person?
You will fall down.
It will fall down suddenly, right? There is a very high chance
Yeah.
that he or she
May
like
get
the
hurt.
fracture, yes, may get injured and there could be a fracture, right? So there you go.
Yes.
So it is dangerous to jump out from a moving bus because the jumping man who is moving with the high speed, there you go. When the bus is moving, so that person is also having the same velocity as that of the bus, right? So when it suddenly jump out from the bus, so there is a change in state, and due to that, the body basically suddenly comes to rest, and that would basically tend to remain in motion even when falling on the ground, and they get hurt due to the resistance offered by the ground, right? So that's why it is not, you can say, preferred, or it's not, you can say, advisable to move out from a moving bus. Clear, Safia?
Yes.
Chalo, that's great. Okay, so any doubt?
No.
No. So this is the first law and the inertia topic. Is this clear to you, Safia? Please let me know once.
Yes, it's clear.
It's clear, Chalo. That's great. Just a second, Safia. So after this class, na, Safia, you will be having an assessment of 5 questions as MCQ assessments. As I've told you in the last class. Okay? So this
Yes.
basically this topic will be based on the inertia. Okay? Inertia that we have done so far. So let me just allow me a second, Vijay. Okay. So these are one more thing, Safia. These 4 statements are very, very important. They are very common in the school exams. Why there is a forward jerk in the when the bus suddenly stops? Why there is a backward jerk, backward fall when the bus suddenly starts? Why it is not advisable to jump out from a moving bus? What happened when you beat a hanging carpet with a stick? Right. So these are very common examples and conceptual questions that are definitely going to come in the exams. Right.
Yes.
Sure, that's great, Safia. So now, Safia, now next topic is basically momentum. So this topic is the last topic of this class. Okay. So in this, basically, momentum is basically, you can say, the fundamental or foundation for the second law of motion. Okay. So let's understand the momentum, because second law is based on the momentum concept. Right, Safia? I mean, in the
Yes.
in the tomorrow's batch class, we will do the second law of motion. So in that, momentum word is used very frequently, and even the derivation is also there for the F is equals to ma portion. You must have heard F equals to ma. Have you heard this thing? F is equals to ma. Force is equals to the product of mass and acceleration. Have you heard this thing?
Yeah.
Yeah. So
Yeah.
this equation is derived from the momentum, right? Now let's understand what momentum is, Safia. So momentum of a body is defined as the product of mass and velocity. The product of mass and velocity is called momentum. It is denoted by P, and the formula is M equals to V. M is M into V, right? So Safia,
Yes.
the SI unit will be mass is kg, velocity is meter per second. So the SI unit for momentum is kg meter per second. Is this clear?
Yes.
Any doubt?
No.
Sure?
Yes.
Right. And one more thing, Sophia, momentum is a vector quantity. It means that it can be negative, it can be positive, it can be zero. And one more thing, momentum, if it's a vector quantity, it means that it will have the direction as well with the magnitude. Clear?
Yes.
Because vector quantities do possess the direction. Yes or no? Vector
Yes.
quantities possess the direction, na? It have the they have the position direction. Right. So that's why momentum is a vector quantity, and the momentum is kg meter. SI unit for momentum is kg meter per second. So what basically momentum is? It's basically the quantity of motion in a moving body. It tells you how much quantity of motion is there in the moving body. Right, Sophia?
Can you explain again? I did not hear.
I said The momentum is basically the measure of quantity of motion in a moving body. The quantity of motion in a moving body is that it basically is the measure of momentum, right? It tells, suppose that Safia, you must have seen a cricket ball. Have you seen a cricket ball? When you
Yes.
throw a cricket, when a bowler throws a cricket ball to the batsman, if the batsman miss that ball to basically miss the hit, so that ball will basically injure the organs like thigh, stomach, hand, or maybe sometimes head. So that ball will basically make an impact. It will hurt you. So momentum will tell you how much it will make impact on the body when it will collide. Clear?
Yes.
Now it's clear, Safia?
Yes, somewhat.
Somewhat. Let me tell you one more thing. Dekho, a cricket ball is not heavy, but when it is thrown with a high speed, it acquires a large momentum and sometimes hurts the batsman. One more example. Suppose that a car is basically not running at a high speed, right? But because of its high mass, car do possess like car basically are made up of like thousands of kgs of metal, right? So, but when
Yes.
it is collide with a body, when it collide with a body, it hurts. Sometimes person may get injured or there is a fracture in the bone. So that tells you now how much impact is making on the body momentum. Clear?
Yes.
Next example, you can say this. Suppose that, Safia, there is a very high car going with a very high speed, and there is an accident happened due to that car, due to the high speed. You can see this thing. The car is basically completely crushed. It's completely damaged. So you can see this thing when the car is moving with a slow speed, the damage is not that much severe. But when the car is moving with a very high speed, the momentum is high because velocity is involved. So when the momentum is high, so there will be high impact. More worse condition will be made in that case. Clear, Sophia, now?
Yeah.
Now it's clear now? So what is basically
Yes.
momentum? It tells you how much motion, quantity of motion is present in the body. Clear?
Thank you.
Right? So a bus or
Yes.
car, so they go. So a ball is very small in size, but if it's thrown with a high speed, they go. If you say this thing, mass is not that much high, but velocity is 150 kilometer per hour, 200 kilometer per hour. So the momentum acquired will be very high. So that will hurt. So you must like in the cricket, in the games like cricket, like hockey, or you can say baseball. If the ball basically collides on the head, strikes on the head, there's a possibility, very high possibility that the person may get died because the velocity is very high. Due to that momentum, the quantity of motion will be very large. So that's why it will make more impact. Clear, Sophia?
Yes.
So that's what momentum is. I hope it's clear now. Do you have any doubt?
No. No.
Sure.
Yes.
Chalo, that's great. Okay. देखो, a car or bus momentum is considered to be a measure of quantity of a moving body of motion. Just a second. Just a second, Sophia. Quantity of motion of a moving body. What is the quantity of motion that is possessed by a moving body? That is momentum. Is this clear, Sophia? Please let me know once. Do
Yeah,
you
it's
have
clear.
any doubt till now? Yes, do you have any
No.
doubt, Sophia? No? Chalo,
No.
that's
No.
great. Now let's do a very basic example based on the momentum. Question is saying, what is the momentum of a man of mass 75 kg when he walks with a uniform speed of 2 meter per second? So mass and velocity is given. So according to the momentum formula, that is m equals to mv, substitute the value 75 into 2. SI unit will be kg meter per second. So 75 into 2 is 150 kg meter per second. Please let me know, Sophia, is this clear to you or not?
Yeah, it's clear.
Clear? So that's how you
Yeah.
will solve the examples of the momentum, the numericals related to momentum. Okay. Now let's do one more question. Question is saying that the momentum is given to you, that is 125 kg meter per second of an object of a body. and we have to calculate the we have to calculate the velocity of a body if the mass is 25 kg, right? Sorry, Safia, for the interruption. Okay. So we have to calculate the momentum of the velocity of a body. So according to the formula of momentum, that is P equals to mv, we need the velocity. Velocity is the variable. So how you will calculate it? Divide the momentum by mass. Yes or no, Safia? That is
Yes.
125 divided by mass is
25.
25 and velocity is asking, so it would be in meter per second. So this will cancel this 5 times. So this is coming out to be 5 meter per second. Clear?
Yes.
Okay. Now, Sophia, please do this question, which I'm giving to you right now. Please do this question and let me know the answer for this.
Did we convert it?
Yes, you have to change the units.
I don't know.
अच्छा चलो कोई बात नहीं, नो वरीज. अच्छा वो आपने बता दिया. देखो देखो Sophia, question is saying that what is the momentum of a toy car having 200 grams of mass moving with a speed of 5 meter per second, right? So as you can see this thing, Sophia, SI unit of velocity or speed is basically SI unit is given to you. But mass is not given in SI unit, that is in grams. So gram is not the SI unit, kg is the SI unit, right? So,
Yes.
so how, देखो, so Sophia, if I want to convert the gram into kilogram, so 1 kilogram have 1,000 gram, right? One
Yeah.
kilogram have 1,000 gram. So I have to divide the 200 gram by 1,000 to convert it into kgs. So two zeros will cancel this. So it is coming out to be 0.2 kg. देखो 110 is there left now, 10 is left, so it will be decimal because two zeros are already cancelled. Yes or no, Sophia? Clear?
Yeah.
Yeah. V is equals to 5 meter per second. 5 meter per second. Now, according to the formula, P is equals to mv point 2 into 5 kg meter per second. So देखो 0.2 into 5. So this will be देखो अगर if you directly multiply it, so 10 आ जाएगा, right? But there is a decimal. So decimal will be placed here. So it is 1. 0.2 into 5 is nothing but 1, na Sophia?
Yeah.
Right? So that is coming out to be 1.0 kg meter per second. Is this clear to you, Bache?
Yeah.
Any doubt so far?
No.
Chalo, that's great. Now let me give you one more question and you have to solve it. Just a second, Safia. Let me take the question from the NCRT because there is one more question. Just a minute, Safia, let me take my question. Yes, Safia. So please do this question in a notebook and let me know the answer. So, like that. Safia, any answer?
I did the first one A. I'm doing
Solving?
the B. Yeah.
Just yes, Safia, you were saying something, which
I finished the first one. I'm doing the
Hmm.
second one B.
Okay, please do the second one. Second one is already simple, Safia. There is no change of unit because it's already given in kg and meter per second. Both are the SI units.
Finished. Yeah.
Finished? Sure, that's great.
Yeah.
Let's verify it. Let me solve it. Okay. So please verify it from my answers. Okay, Safia?
Okay.
So question A is saying an elephant of mass 2000 kg and moving at a speed of 5 meter per second, because you can see this thing. Elephant is of very high mass, right? And speed is 5 meter per second. So we have to calculate the momentum. So mass of the elephant is 2000 kg. Velocity is given to you as
Yeah.
5 meter per second. Okay. So according to the momentum, that is m into v. So that is p is equals to m into v is 2000 into 5. So this is coming out to be 10,000 kg meter per second. Is this clear to you, Sophia? Please let me know this.
Yes.
Any doubts so far? Okay. Next is a bullet of mass 0.02 kg, 0.02 kg, and velocity is given as 400 meter per second. So you can see this thing, how much high velocity it is. 400 meter per second, right? So we have to calculate the momentum, that is m equals to mv, that is 0.02 into 400. That is the, can I write this 2 as 2 into 10 to the power minus 2, Sophia? Two decimals are there. If I want to remove this decimal, I have to divide it by 100.
So
Check,
if you put up, it will be 10 raised
just
minus 2.
check. Can I write this thing as 2 by 100?
Yes.
0.2, right? Into, can I write 4 as 4 into 100?
No.
Yes or no?
Yeah.
So 100 will get cancelled. 2 4s are
8.
8 kg meter per second. Clear, Safia?
Yeah.
That's the same answer you got?
Yes, but I wrote
Shabbash.
8.00.
No issues. That's not an issue. If you write 8.0, so that is also same. Doesn't matter, right? So let me take one more question, Safia. Just a second. Okay, Safia, let's do this question. Please try this question and let me know. At least try. If not, I will help you or I will explain you.
Is the initial momentum 5 kg meter per second? The first one.
Yes, Safia?
Uh, the initial momentum is 5 kilometer meter per second. First one.
Oh, 5 kg meter per second.
Yeah.
Okay, for the next one.
I don't know how to do that.
Okay, at least try. Think a little bit. It's related to the equation of motion. Think a little bit. I will explain it. No need to worry, but at least give it a hint, like give it a try once more.
Is it 500? 60 kilometer per second.
Okay, now let's discuss it. Bye bye. First answer, okay. Question is saying a man throws a ball weighing 500 gram vertically upwards like this. Suppose that ball is thrown like this. Okay, Safia? Say yes or no. Clear?
Yes.
Okay, yeah. So it means that, so first of all, let's write down the mass is 500 grams because this is not the SI unit. So you want to divide, you have to divide it by 1000 to make it kilogram. Two zeros will get cancelled. So it is coming out to be 0.5 kg, right? And velocity is given to you 10 meter per second. Okay. So let's write down the formula. P is equals to mv. So that is 0.5 into 10. So it is coming out to be 5 kg meter per second. Okay? That was straightforward. Second one. Question is saying what will be the momentum at the highest point of flight? Suppose, Safia, the ball is thrown at this point. So at the highest point, the velocity, the ball will stop, and after that point, the ball will basically drop from that point. Yes or no? When you throw a ball in the upwards direction, at a certain point, at the highest point, the ball will stop, and after that, the ball will start to fall. It's asking highest point of flight. It means that at the highest point, the velocity of the ball will be zero. And if the velocity is zero, so the momentum will be at that point would be zero because mass into zero is zero. Clear, Safia? That's why I give you this question. So mass is same 500 gram is into 0.5 kg में convert हो गया ये. And velocity will be zero, Safia, because at highest point the velocity will be zero. So mass into velocity, that is 0.5 into zero, that is zero. Please let me know if it's clear to you, Safia. It's clear?
Yeah.
Okay, let me give you the examples, some more examples, so that you can at least understand it properly, right? How do you find this chapter interesting or not?
No.
No? Seriously?
Yeah.
I thought you will be finding. चलो कोई बात नहीं. Just a second, Safia. Just a second. So let's do this question. I got one question of the NCERT, Safia. Would you like to give it a try?
Yeah, sure.
Sure, that's great. I like the spirit. I like that's the confidence I wanted to build. So that is the reason I give questions in the first instance. Okay? Because that helps you to build up your confidence. At least give it a try. Just if you give it a try, then that will boost your confidence. Chalo, please solve it. try to think what is the use of this acceleration, what is the use of this height, because mass is given, two quantities are there, and you have to derive the velocity from these two quantities, that is velocity, acceleration and the height. I'm giving you the hint.
No, I didn't get it.
Didn't get it? Okay, so let's discuss it. कोई बात नहीं. Okay, so let's solve it, Safia. Question is saying that how much momentum will a dumbbell of mass 10 kg will transfer? So सबसे पहले, first of all, we have to write all the things given. That is 10 kg of the mass is given of the dumbbell bell, right? And it will transfer from a height of 80 centimeter. The centimeter is not the SI unit. So I'm going to denote it with, it would be 8.8 meters of here, because in 1 meter, 100 centimeters are there, right? So let me write
Yes.
it properly. So it was 80 centimeter, that is 80 by 100. So it is coming out to be 0.8 meter. And downward acceleration is given to you 10 meter per second square. So Safia, as you can see, this thing, distance covered is given to you, acceleration is given to you, and one more thing, Safia, the ball has basically the ball is falling from a height. So at a certain at the point of collision, the velocity will become zero. Yes or no? Sorry,
Yeah, it becomes 0.
sorry. Initial velocity. Sorry, initial velocity will be zero. No, sorry. I just forgot. When the ball is
The
like this, just a second. When the ball is basically in the air, you drop the ball like this. Suppose that I have a ball. देखो ये है. Just a second, let me remove my background. Choose the, देखो, I have this ball, right? So the velocity of this ball is right now,
10 meter per second.
no, it's zero, Safia. There is no movement. How is it possible to have a 10 meter per second velocity? When it will drop, the velocity, there will be a velocity when it will drop. देखो, starting in the start, the ball is in rest, right? So initial velocity would be zero. Because they go before collision, the ball will have the maximum velocity that it can reach before collision. So there will be some momentum transferred because the ball has some velocity before the collision. And if the ball has some velocity, so it means that there will be some momentum as well. Clear? Is this clear till now? Yeah. Right. So as you can see, this thing, Safia, we have distance, we have acceleration, we have initial velocity. So there is a third equation of motion, v square minus u square is equals to 2as, that helps you to find out the final velocity of the ball before collision. That's why I told you that two things are given, you have to find the third thing, right? So v square you have to find, minus 0 square will be 0, 2 into acceleration is 10 into 0.8. Is this clear, Safia?
Yes.
Next so it would be v square will be equals to, देखो, 0.8 into 10 would be 10, 8. 8
Yeah.
into 2 is 16.
16.
So value of v will be equals to root 16 meter per second. So it is nothing but 4. The root of 16 is 4 meter per second.
Per second.
Clear, Safia?
Yes.
So now the velocity is obtained using the third equation of motion. Now what we can do is that we have to find the momentum. M into V. So that is mass is 10 and 4 is, so it is in kg. meter per second. So that is 40 kg meter per second. Please do let me know, Safia, if it's clear to you or not.
Yeah.
Clear?
Yeah.
This is a very simple question. As you can see, there is no that much calculation. Only three steps were there. But only thing that you have to understand is the use of the height and the acceleration. That's why motion chapter is also important to understand the force chapter. Because for the equations of motion are applicable in the motion chapter. Clear, Safia?
Yes.
Please write it down and let me know.
Done.
Okay? Okay, sure, that's great. So this is okay. So these are the questions in the momentum part. Is this clear, Safia?
Yes.
So I hope
Yeah.
so. So this is all about this topic.